This video is on integration using residues. In today's video, we are going to solve a problem using residue theorem. In this video, we are going to evaluate integral z squared plus 2z minus 2 by z into z minus 4 into z minus 1 into dz, where c is mod z is equal to 1.5. So here it is given that integral f of z dz is given. So what is our f of z value? So f of z value is clearly, that is z square plus 2z minus 2 by z into z minus 4 into this is z minus 1. So we have to equate the denominator to 0 for getting the poles. That is z into this is z minus 4 into this is z minus 1 to 0. If I equate z to 0, so z is equal to 0 is a simple pole. So if I equate z minus 4 to 0, z is equal to 4 is another pole, and z minus 1 to 0, so z is equal to 1. So these are the simple poles. So we got z is equal to 0 as one pole, z is equal to 4 as one pole, and z is equal to 1 as one pole. And here the circle is given as mod z is equal to, see here, this is mod z is equal to 1.5. So this is 1.5. So which is nothing but z minus 0 is equal to, this is 1.5. So it is a circle with center 0 and radius 1.5. And let us check whether these three are inside or within or on the given circle. So this is a circle here. So this is 0, 1, 2, 3, 4, and this is minus 1, minus 2, minus 3 and minus 4. And here this is minus I, minus 2I, minus 3I, and this is I, 2i and 3i. So here if you observe this one, so with center 0 and 1.5 radius, this is a circle. Mod z is equal to, this is 1.5, and here z is equal to 0 is within the circle, and z is equal to 4 is outside the circle, and z is equal to 1 is also within the circle. So 0 and 1 are within the circle and 4 is outside the circle. So we have to find the residues for these 2 points. For finding the residues at a simple pole z is equal to 0, this is residue of f of z at point z is equal to 0 is nothing but limit z tends to 0. This is z minus 0 into f of z. So which is equal to, this is limit z tends to 0. Z minus 0 is nothing but z, and here f of z is nothing but z square plus 2z minus 2 by this is z into z minus 4 into this is z minus 1. So if I cancel this z and substitute 0 in the rest of the function, so here the numerator is minus 2 and this is minus 4 into this is minus 1. So minus 2 by plus 4. So this value is half. So this is the residue value. This is the residue value of f of z at point z is equal to 0. At point z is equal to 0, minus half is the residue value. At the pole value z is equal to minus half. And the next one here, z is equal to 4 is outside the given circle. Therefore, there is no need of finding the residue value. And again, z is equal to 1 is within the circle. And therefore, we have to find the residue point. See here, the residue at point z is equal to 1. Residue of f of z at point z is equal to 1 is nothing but this is limit z tends to 1. This is z minus 1 into f of z. So here this will be limit z tends to 1, z minus 1 into f of z. So what is our f of z value? F of z value is nothing but this is z square plus 2z minus 2 by z into this is z minus 4 into this is z minus 1. So if I cancel z minus 1 and substitute in place of z as 1, that is 1 plus 2 minus 2 by this value is 1 minus 4. So if I cancel minus 2 and plus 2, this will be minus 1 by 3. And this is the residue value of f of z at point z is equal to 1. So we got the residue values at the interior poles. Therefore, now we have to apply residue theorem. So by residue theorem, we have integral f of z dz as this is 2 pi I into the sum of the residues at interior poles. that is integral z square plus 2z minus 2 by this is z into z minus 4 into z minus 1 into dz value is equal to 2 pi I times of the first residue value is minus half. At 0 the value is minus half. So this value is minus half, and the next value is, this is minus 1 by 3. Therefore, this will be 2 pi I times of minus half minus 1 by 3. So this is 2 pi I times of, if I take 6 LCM, this is minus 3 minus 2. So this value is 2 pi I times of, this is minus 5 by 6. So if I cancel, this will be minus 5 pi I by 3. So this is our integral value, that is integral z square plus 2z minus 2 by this is z into z minus 4 into this is z minus 1 into dz value is nothing but minus, this is minus pi I by 3. So this is how we have to solve, and let me explain you once again. So here the question is given as integral f of z dz. So f of z is taken as this one. If I equate the denominator to 0, so there are three simple poles, z is equal to 0, 4 and 1. And here our circle is given as mod z is equal to 1.5. It means that it is a circle with center 0 and radius 1.5. With center 0 and radius 1.5, this is a circle, and 0 and 1 are within the circle and 4 is outside the circle. So we have to find the residues at these two pole points 0 and 1. At 0 the residue value is minus half, and at 1 and at point 1 the residue value is minus 1 by 3. Therefore, by residue theorem we have a formula that integral f of z dz is nothing but 2 pi I into sum of the residues, that is minus half minus 1 by 3. So this is minus 5 by 6. So if I cancel, minus 5 pi I by 3 is the required solution. Thank you so much for watching. If you really like, please practice, and definitely you can solve by your own, and please pass it on to your friends, and keep watching my upcoming videos. Those are also very useful for you, and these videos are the previous questions. Please don't miss to practice. Thank you so much.